talk with you today about Corvettes and about the plant, which I absolutely love. So before we get into the presentation, I want to give you a little bit of background on myself. So I started working for GM just 2 weeks out of high school. I entered into the engineering program. I'm a mechanical engineer by trade. I also have a master's in business administration. So I've really got over 30 years with GM, and I don't look that old, but I do. And this is my 7th GM location. Started with engines, transmissions, had an opportunity to work in Europe, Michigan, and now Kentucky. And it's just a privilege to work here. It's an honor to be part of the Corvette team. And I truly love it. I truly can say that I love my job. I love my job so much, and I love the product that we build. It's just an awesome vehicle. The steering, the braking, the balance, the exterior styling, the interior styling. It's just an awesome vehicle, so much so that last year I bought my own Corvette, 2017 Grand Sport. I absolutely love it. So that gives you an idea of who I am. And we'll go ahead and get started with the presentation. We're going to talk about where we've been, where we are, and where we're going. And this first photo over here on the left is actually from 1981 when we started building Corvettes in Bowling Green. So there's some history. The center picture, and I apologize for the screen being a little bit dark, but the center picture is one of our C7s coming off the end of the assembly line. It's the black rose, and so that's the center picture. And then over to your right is from the paint shop. Yes, the new paint shop. It's what we call our scuff, or the carrier, that the panels are mounted to as they go through the paint shop. Okay, we're going to start with employee engagement. We're starting there because the employees are the most important part of the business, right? And then we're going to start in the upper right-hand corner. It says GM GMS. That stands for the Global Manufacturing System. That's the system that we use in Bowling Green and that all of GM plants use in their manufacturing system. Kind of shows like an atom there. And there are 5 main principles that are made up of GMS. But the one of the principles is standardization, which talks about the job instructions that are used, built-in quality, robust quality systems, short lead time, the right parts at the right time, and continuous improvement mindset that we want to get better and better. The one that you can't see up there with this, because the screen is limited, is people involvement. And people involvement is the most important principle for me. Because you can have robust quality systems, you can have good job instructions, but what takes you from good to great? It's the people. And it's the engaging the people in the business. So that's why we say employee engagement. One of the ways that we get employees interested and more involved in the business is through safety stars. So we'll ask the teams, please have one of your team members volunteer to be a safety star. And we teach them more about the safety systems, and then they take those messages back to the team. And I'm happy to tell you that Bowling Green Assembly is the safest General Motors plant in North America. We have the best safety record throughout North America. Okay, you see 0 defects? Again, that's a mindset that we want to build quality in the station. Down in the lower right-hand corner is one of our engine builders. And again, we're focusing on quality, doing it right the first time. And you may know that the engine has hundreds of different parts. And then in our Performance Build Center, where we build the LT4 engine going in our Z06, is they hand build that engine. They start with the block, and they follow that engine through the entire process. Now there's over 200 fasteners, and we have all electronic torque control tools. if you're running that tool and you let off on that tool just a little bit, you're not going to get the green light. Now you're going to get a chance to back up and re-tighten the fastener, and it's not going to leave the station bad, but it was first time not perfect. Well, when we get an engine builder that can build an engine 100%, we say that's a perfect engine, so never had to back up and retighten. And he can do 10 consecutive engines in a row. We call that a perfect 10. And that's a picture of one of our engine builders who got a perfect 10. And he got a special shirt. And that is the award. You might recognize that as a piston rod assembly. So he gets that award that says perfect 10 and shows on the other side, it shows a picture of the engine. So that's our perfect 10. So that's how we get our employees engaged in the business. Another way is this symbol called Protect the Vet. So as the Corvette is going down the assembly line, we want to protect it from any scratches, any chips, anything that might happen to it, any mutilations as we call it. And we want to encourage people, if they see something that could happen, that could result in some kind of damage to the car, we want them to raise their hand and speak up. So this is a photo of one of our employees who spoke up when they saw something that could happen to the Corvette, and he's holding in his hand a hat that has the emblem of Protect the Vet. So again, it's the mindset, it's recognizing what could go wrong, and thanking those employees for that right kind of behavior. On the top left hand is a picture of one of our meetings with our professional managers network. So our group leaders or supervisors, all the support folks in the salary organization, they have a network, and they get together typically once a month where we're giving them additional information. They get a chance to talk to one another, and again, helping to support our salary organization with employee engagement, and that's through our professional managers network. Okay, virtual training. So some of you are well aware that we're in a construction phase right now, and later in this presentation I've got some photos that I can share with you on what's going on with our General Assembly. So our hourly folks are laid off, but we are bringing them back 1 week at a time, and we're training them to what will be a new setup in General Assembly. And we can do that through a program through 3D modeling. And it simulates all the jobs in General Assembly. And it's a multi-level program. So when you start at level 1, it prompts the employee as to what is the task that they need to do, what tool they need to get, what parts they need to get, and it's tracking that employee's each click that they make on the computer. And it's helping them, assist them to learning the new job. And then as the levels go on, there's less prompting, so there's less support because the employee is learning and memorizing the new jobs. So the goal is to train the memory and to be able to practice for their new job. And this method has been tested, and we know that it will lead to significant increases in productivity while maintaining safety and quality. So I've got, the top picture is just our training room. It's a picture of some of the employees just this past week that were going through the training process. And I've got a short video that was taken. This is the simulator that the operator would be looking at as they're working the computer. They're actually clicking on what part do I pick, what tool do I pick, and ensuring that it's in the right sequence. Okay, down here you see a picture of the car, and this is what area the employee is working at. It'll show which tool that they need to pick up. Or maybe it's a visual check, it could be the eye. Here's some of the tools and the parts. It's giving them information as to what they are required to do. It also gives them information how to do it and why they should do it. We have this for the entire car, the entire process in assembly. When an employee learns one job and they reach the level 4 and they do it in 20 repetitions, now they can move on to job number 2. And we've had some of our employees, they're able to learn multiple jobs through the computer. So we do these computer sessions in 4-hour increments, about 4 hours, and you've had enough time on the computer. After they go through this session, and they reach the level 4, then they can move on to a building on the north side of the plant where we have, that's our training facility, and now they get to do hands-on training. 4 hours of computer training, 8 hours of hands-on, and then they come back to this computer for another 4 hours. And this is showing them, again, it's recording for that team member. Were they able to complete all the tasks without help, in the right sequence, and it's recording how many times that they were able to repeat those tasks. So it's really been a great way. It's going to reduce the amount of time for the employee to learn the new job in our new General Assembly. So here's a picture of the hands-on. This happens to be the cockpit. So maybe you can see the part of the windshield frame. And here's the steering column going in. So then after the employee had completed that 3D simulation, then they get to come out and actually do the hands-on practice. Again, people engagement and people involvement is number 1. Here's a picture. This is about the way my car looks. Yeah, it's a Grand Sport with the Heritage package. And what we did is we gave the employees an opportunity to submit photos. They could submit 3 different photos. And we took this Grand Sport poster and we turned it into a mosaic. And it's now in our cafeteria. It's 7 foot by 14 foot. It's posted there. And when you zoom in on it, it's the faces of our team members at our assembly plant. So, and any of you that have been at the plant, you know there's a great sense of pride with our team members. So that's about the people involvement portion. Now, where we've been. We had one of our interns, Phoenix Turner. I have to give him the credit for this video that we're going to watch. We wanted to capture the history of the General Assembly process. So he went through and he videotaped it, and it's at a sped up speed, and he put it to music, and let's watch it. I never get tired of watching that video because it reminds me of all the different cars that have been built. Some of you in the audience, maybe you have came and watched your car being built, and many visitors in the plant. As I watched the video and I said, oh yeah, that's the tour stop. Yeah, that's when the car touches down. And it's just a great history to have. So I'm so glad that we captured that on video. The last car built was a red Stingray. I do have the VIN number. I know some of you might be interested, so afterwards I can give that to you. Just a couple other photos. The first one was the door ring. Here's on the 3 rail. This is actually looks like the end of trim going on the 3 rail, and then tire and wheel assembly. Again, this is the last C7 in the old process. Now we're going to start calling the old general assembly process. Now, touchdown there as you come around chassis verification station, as we call it, onto the final fit. So all 4 wheels touch down. This is a sight that I've never seen before, and that is that there's just one car on the flat track coming to the end of the line. And then the employees that were available gathered around and we got a photo. So history in the making there. Okay, so now let's talk about where we are. Well, I know some of you that were at the bash, we talked about this extended shutdown that we're having in the plant. It's happening now. This was just, we were ending up what we call week 5 of a 13-week shutdown. When you look at the roof of the plant, the area that is brighter white here is the new paint shop. This is our manifold building, or connector building as we call it. This is some photos that were taken here recently, some areas of the plant. So we took about 2 weeks for demolition. And I was sharing with Ron earlier, there was over 4,800 tons of scrap steel that we took out of the plant. So on the conveyor system for General Assembly, you know, it was some portions over 30 years old, and a lot of that old chain, that old conveyor came out. Some of the floor, we had to do some, we had lay new concrete. This is just some overhead rail that's staged ready for installation. This area here, it looks like a bunch of soldiers. If you remember, if those of you that have been in our plant, we have airproofing, most of those stations being electronic torque tools, but we also have kick lights and scanners, and this is for the airproofing system. So a number of those we took out and saved, and those will be reused, and then we also have new. Some more photos. Now you see that this rail is being installed overhead. This is part of the conveyor for the skillet line, and I'll talk about that a little bit later. This is just, normally we would have production parts in this area, but now we're staged with a lot of the equipment for assembly. Okay, at the same time, we have our new paint shop coming online, and we are on track to our launch plans. We're currently starting to fine-tune the robots, the robot paths for each of the different colors, and we call that our workability, so we're in the process of doing that and validating all our processes. We got a little short video here, let's watch. Okay, you'll notice now, first thing I noticed when I watch this is the robots are overhead. So there's actually a rail, there's a total of 6 robots per booth. And if you went to Fairfax plant or you went to the Flint plant, GM assembly plants, you would also see that the robots are overhead. These are new FANUC robots. It's showing that we're painting white here, obviously. So that just gives you a little snippet from the new paint shop. Okay, where are we going? And I would say the first leg of trim, so if you went on a tour, you came from the tour room, and you started down the assembly line, that first leg of trim is physically about the same. The arrangement of the work will be different, but the trim is going to be somewhat the same, that first leg. Here's a photo from cockpit. So cockpit assembly had been on the carrier was from an overhead conveyor, chain conveyor, fixed. Now the construction area, so this is the old, you can see the window frame there, part of the cockpit assembly. This is the area of construction a couple weeks ago when we started the new cockpit line. And this is a pallet, and this is a fixture, and it has the ability to rotate, so that's why that wheel is there. There'll also be a little platform for the kit, for parts that go into the cockpit. And these are all the pallets lined up and part of the new cockpit assembly. It'll be driven by AGCs, that automatic guided carts that are more flexible than the old chain conveyor system. This is part of chassis sub, and again the car is overhead on the 3 rail, and then this is the tow veyor that the chassis would line up as we get close to the marriage station. You'll notice here, this is the old, we called it tow veyor. It's again a chain conveyor running on the floor. It also had a pit area. And again, it wasn't as flexible as our new system will be run by AGV, automatic guided vehicles. Here is a picture of one of them. And if you'll notice on the concrete floor here, it's kind of a gray, dark gray tape. That's the metallic tape that the automatic guided vehicle, it tells it what direction to go. If we wanted to change that path, we'd pull up that tape and put it in a different direction. So that's what I mean when I say it's much more flexible than our old tow veyor system. Okay, here's marriage. Again, this was the old tow veyor system, car on the 3 rail, and this is the way it looked a couple of weeks ago. And so I'm going to stop here and just tell you a little story. So the first 2 weeks in August, all the salary folks took vacation, the most part. Some launch people were still working. So I got back in the plant on August 14th, and I got my PPE, my personal protective equipment, so that I could go out in the construction area, which means I had to get an orange vest, I had my hard hat, I got my glasses, I go out on the floor, and I start walking the floor, and I was just stunned. I mean, I've known for several years that we were going to do this project, but to see it in real life, and to see this area that used to be marriage, and it's just blank, you know, and all the construction people, it's really a bigger undertaking even than I imagined when you see it some real life. I was kind of like, wait a minute, I used to know where every part on the Corvette was installed, and which section of the conveyor I could take you there, and now it's going to be totally different. But that was a couple of weeks later. Like I said, we just finished week 5, and now you start to see it come together. And now I get to see the skillet lines, for example, being put together, and to see how it works, which is exciting for me as a mechanical engineer to be able to see everything as it's going back together. So talking about that, talking about the skillet lines, these are rollers. So the skillet is a large platform that the car is mounted to. And there's several advantages why we wanted to go to skillet lines. And skillet lines are not unique to Bowling Green. It's in our Detroit Hamtramck plant, our Spring Hill plant. Many of our assembly plants have the skillet. But it allows us to lower or raise the car. It's a kind of accordion in this area, so we can put the car at the exact right height that we need for our team member as they're assembling. Also, this now is going to be on the chassis of the car. It's going to be sitting in and simulating as it would be on the 4 wheels of the car. So as we're assembling the exterior panels, we expect, when we have touchdown again on the 4 wheels, that we're going to see less movement in the panel, and we should be able to have a better fit earlier in the process. So that's the skillet line, lots of construction going on in that area. Door sub-assembly, again, it was an older system. Here's the fixture that holds the door, running by an overhead conveyor. The new system, pallet style. This little frame here is where the kitting would go for the parts going on the door. This is an example of one of the pallets with the fixture that the door would be mounted to. And here's the little AGC, or automatic guided vehicle, that moved those pallets around. Okay, I know anybody that was here for the bash back in April might have saw this slide, decided to reuse it. So again, you can remember, this is the old trim line where we put in the convertible top, and we put in the quarter, and we put the hatch on, and we put the seats in. Well, all of these exterior components are now going to be put on the skillet line. So I just talked about the skillet line. It's going to move in this direction, it'll be shoveled down, and then it'll move in that direction. And all the exterior panels are going to be put on, with the exception of the door ring, it'll still be put on in body. All those will be put on in the skillet area. And we're doing that for a couple reasons, right? So we want to reduce the likelihood of any kind of chips or scratches. So putting them on later in the process is good. And also, when we put these panels on close together, then team member to team member, team to team, better communication on the fit of the car. Okay, the other thing, one of the other main reasons where we're doing all this rearrangement, what we're going to gain out of it is material delivery. So today, I'll say the old process was that 75% of the parts in General Assembly were delivered by fork trucks. Fork trucks can weigh 10,000 pounds. They have a counterweight in the back. Whoops, didn't mean to do that. If you get hit by this fork truck, the fork truck's going to win. The other thing about the fork truck is when you're sitting here, you don't have a clear sight of vision. These masks are actually become blind spots. In the future, our new method, 75% of the parts will be delivered by tugger. Now, the individual who's driving this vehicle has a clear view. So we're going to be moving away from bulks delivery to small lot and kitting. So we're going to have a smaller number of parts, smaller quantity delivered to the team member, so there'll be less waste in the form of walking, because the containers can be more compact with the parts needed for the team member.